See, that's how we help each other out, everybody. All right.
Thank you.
3.5 feet. And I want to convert that to inches. I would put feet here, inches there. 1 foot, 12 inches. So this is what we said first. If I had feet to inches, I would multiply by 12 once. If I have square feet, if I just do this, have I completely gone to inches squared yet? No, I really, can you guys see this? How many feet? That cancels with one of these. So then I'm going to end up with foot inches, right? So I would have to do this one more time so that that cancels with the other one. Inch times inch is square inches. Do you guys see that? If I could just figure out how to orient this, you might be able to see that. Maybe? No?
Professor,
Yes.
Would there be any situation, at least during this class, when we are using this, let's just call it formula, where the bottom won't equal 1 and we'll have to do a different step?
Of course. Real quick, just to address, well, let me do this first, and then I'll come back to your question. So if I take this step of what I'm going to have to do now to actually do what the problem says, I'm going to have to do this 3 times, of course, right? Because how many of these do I have to get rid of? 3. Does that make sense? Does just that by itself make sense?
Yeah.
If the answer is no, it's okay. If the answer is no, it's okay. Because that's my job, is to re-explain something in a different way if it doesn't make sense.
No.
Are you
no, just
cool?
one more time. Yeah, I just need
where do I lose you? We're obviously, or no, let me not say it like that. Are we okay here? And this is where you would get 42.
Because you're
If it was
multiplying 3.5 times 12, right?
Yeah, if it was just first power feet, if it was just feet.
Okay.
Because once you multiply by 1 over foot, you're done. You're there. But here, you have to get rid of square feet. So then how many do you need? 2 of them.
So you do it twice. You do it twice.
Yes.
So square.
Yes. Does it make sense? Because the exact reason we do this once, because have I killed my old units? Yes. Am I where I want to be? Yes, I'm done. If I do this once, have I killed both of these? No. Oh shit. I got to do it one more time. So here, how many am I going to have here? Because I have cubic feet.
3.
And then you can see 2 things. Foot is cubic feet. Inch times inch times inch is cubic inches. So then you know that your units are correct. That's unit analysis. And now you do the math. This times this times this times this. That's how that works with higher, this is going to be a neat phrase, higher dimensional units, right? If I have a first dimension unit, just the length, I only have to do it once. Area is 2 dimensions, I got to do it twice. Volume is 3 dimensions, I got to do it 3 times. All right, now coming back to, I can't remember who asked this question, but I'm going to erase this. Any other questions about this? Okay. And now it's gone out of my head. Oh yeah, that's right. What if I wanted to convert 700 cubic inches and I want to convert that to cubic feet? What would I have to do? Where to start this off, where would inches go?
On the bottom.
On the bottom. And I'd have to do that, of course, how many times?
3 times.
3 times. And what would be here? What number? How many what's and what?
12.
What is it that you're trying to do
12.
again?
Huh? Sorry?
You're trying to convert what into what? I'm sorry.
From cubic inches
Uh-huh.
to cubic feet. Right. So the only difference now, I'm still going to have to do it. Let me make some more room over here. I'm still going to have to do this 3 times. That's the thing we just spoke about, right? Because now I got inch times inch times inch is cubic inches. Together, they all team up and kill this dude, right? Inches assemble. Die. Okay. Little inch Captain America and stuff. He picked up the hand. Okay, I'm sorry. And then, of course, you get foot is cubic feet. So you're going to end up. And is this your question? Do you see how the bottom is not 1? Is that your question? Somebody was asking, when is the bottom not going to be 1?
Yeah, that was me.
There, that's it. It just depends on whatever unit this is going to tell you what has to go here. Is that cool?
Yeah.
Okay. And then, of course, once you put the units down, you put the numbers where they go. You put the numbers depending on what the conversion is. So the 1 could be on the top or the bottom. It just depends on where I start. I like it.
So then when you do the math, you would multiply 700 times 1?
Sure. So I wouldn't even do that. I wouldn't even do that, of course, right? What would I put into my calculator to do this? 700
Divided by 12.
12.
divided by 12.
Divided by
Divided by
12 again.
Yes. Anytime you have a number at the bottom, divide. Number at the top, multiply. Since the top is all 1s, I actually don't have to multiply by anything because I can do that in my head, right? It's just going to be itself.
So bottom is divide and multiplication is up on top.
Yes, and we all know this. We all know this. It's
You
just
told me that, yeah.
But we know it. I know you know it. But
I know, you told me. You know, I know
Let me
you know that
finish.
I know.
Let me finish my
I just need
thought.
to remember.
Let me finish my thought. We all know this. It's just that we assume that everything changes when we start doing something else. But the math behind this idea can't change. These are just fractions. That's all they are. So they're going to have to act like any fraction ever in the world, in the universe, like, or all the universes.
So
Yes.
what can we use this conversion table for? Inches,
Oh,
feet? What can we not,
ready?
what can we use it for? What can we not use it for? Because
do you have
that's
an
important to
example of
know.
something you think it might not work for?
No, I don't know.
Okay,
I don't know.
okay.
That's why I'm asking.
Anything, listen.
Okay.
Anything that you have a conversion for,
Uh-huh.
you can use a conversion table to convert. In any situation. So like, is 1 foot equal to 12 inches by definition? Yes. So that's across the board. In a specific problem, like today we're going to look at scale. On a map, could 1 inch represent 25 miles? Yes. Is everybody cool with that? Is that across the board? No, it's only when I'm using that map. But is that a conversion? Does it tell me how 1 unit compares to another? Yes, so then I can use it in the table. This table will work for any conversions that we're given. Either conversions that always work or specifically to a situation like a map or a currency, right? And a currency is specific to the type of currency and the minute that you look up the conversion, right? Because they are always changing. And of course, in Peru, it depends on who you pull over to on the street to convert your money with. One guy gives better rates than the other guy. All right. At least I'm sure other countries the same way. Anybody? Is that okay, everybody? You guys all right out there? Okay. This is what I live for. And I really try not to. These questions are not easy. Although I try to show you how they really should be, but why are they not easy? Because you don't know what properties carry over. Like in this situation, what's the same as before and what's different than before, right? I understand those kind of questions. Those are great questions and dumb in any sense because it's a different situation. Okay, that's enough, Jeff. Anything else from quiz or homework? Yes.
For example, with this conversion chart, how would
Yeah.
we go? We're going from inches to feet here. What would we do to go to inches to yards?
Okay. So you could either, come on, camera, what are you doing? My camera is taking the day off. There we go. Okay. All right. So you want to go from like cubic inches to cubic yards?
Yes.
Sure. Okay. One thing you can do, if I want to go from inches to yards, what would I have to go do?
Feet.
Yes.
And okay.
So one way to do this, don't write this down. If I had like 8,000 cubic inches, I could do inch to foot, inch to foot, inch to foot. Then I'd have to do foot to yard, foot to yard, foot to yard, right? Does that make sense by itself? Inch, 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 die. Now I'm in cubic feet, but is that what I want? No, I want to go from cubic inches to cubic yards. Is everybody with me so far? This was okay for the problem we just did because I wanted to go to cubic feet. But now I want to go to cubic yards, so I'd have to do foot to yard, and I have to do this 3 times to kill each of those. Now, is there a quicker way to do this? Yes. There's a quicker way to do this. And you can do this anytime you want to. In fact, we've already done this once, haven't we? How many seconds in an hour? Haven't we already done this once? How many seconds in 1 hour? What is that? How many seconds in a minute? 60. How many minutes in an hour?
60.
60.
So like
How many-
3,600?
3,600. You got to multiply 60 times 60. That's okay, Martine. I understand. You had the right idea. All right. So look what I did there. I made something that would normally be a couple steps into 1 step. So now watch. 1 yard is how many feet?
3 feet.
3 feet. 1 foot is 12 inches. So 1 yard is how many inches? Same idea as this. Every yard is 3 of these. Every foot is 12 of these. So every yard is
36.
36 inches. All right, let me stop for a minute. Do you have to do this ever? No. Why does it make sense to do this? So I got less to write on certain problems, right? So now to do this problem, now I'm going to do this problem and I'm going to show you an even better shortcut than what this is. Can I go directly from inches to yards now? Yes. So inches to yards. Inches to yards. I have to do it 3 times, of course, right? I have to do it 3 times. So inch times inch times inch, all gang up and kill this guy. But now I can say 1 yard is 36 inches. 1 yard, 36. 1 yard, 36. 8,000 divided by 36, divided by 36, divided by 36. And you know, whatever the shit that is. 1,600.
Wait, okay, so
48,000.
so we
6, is that 0.16? Anyway, what's up? Sorry.
so we divide 8,000 by 36. and
How many
then
times?
3 times?
3 times.
So we divide it by 36 and then we divide the, not the product, that's addition, but yeah, or multiplication. But yeah, we divide it by 36 and then we divide that by 36 and then we divide
You
that by
divide it-
36.
3
Yeah, but-
times. You divide it 3 times.
Put all this in your calculator. Let the calculator worry about it. Right? You don't have to do this and then write that whole number out. No, just tell the calculator to do all this shit for me, calculator.
Then you multiply.
Well, by one, who
It's
cares?
8,000. Yeah, it's 8,000. And so you just, okay,
8,000.
same thing. But on top, if it weren't a 1, you'd multiply, you do the same thing, like you divide the same way. Okay.
Yep. If there was a 7 up here for some reason, I would times 7 somewhere. Yep. Top is multiply, bottom is divide.
And so this is to see,
How many, given a certain number of cubic inches, how many cubic yards will that be, right?
How
I
many
think the
yards
answer is
is
around 0.16. Can somebody see how off I am on that? That's what he
I
did.
got 0.171 and
Look
a
at
bunch
that.
of change.
Look at that. I had some good caffeine this morning in my coffee. Come on, guys. It's my one skill in life is math. That was pretty good. I'm sorry. So, well, I'm sorry. It was 0.17 something or other.
Yeah, 171.
171 cubic yards. So if I have something that's 8,000 cubic inches in volume, that is 0.171 cubic yards. Let me make sure let's get a little freaky there.
for number 60, I got 42.
But again, remember, I showed you where that number came from and why it was wrong. And that's one of the first things I did.
Oh, so 42 is wrong?
Definitely.
Oh,
And
my
now listen,
gosh.
that was the problem. Now, again, I'll do this one more time. That was that problem. What was it? Tell me the problem again. Nancy?
I'm looking it up.
Okay.
Okay, the problem is a hot tub pump circulates 3.5 cubic feet of water per minute. How many cubic inches of water does it circulate each
Yeah.
minute?
3.5 cubic feet. So what you did is you did this once.
Only once.
That's
I need
not
to do
correct. I
twice.
really want you, and look, watch. So foot cancels with one of these. So now there's 2 of these left. So you would have 42 square foot inches. 42 square foot inches. That is your units. That doesn't make any sense,
Yeah.
right? For one thing, that doesn't make sense. And also they want cubic inches. So again, what did you do wrong? Well, how many feet is there to kill here to begin with? 3. So how many of these do you need?
3.
3. So then you have to multiply 3.5 by 12 once, twice, 3 times.
That's why I'm asking, because I remember in the book when I read, it's more than once. So yeah. Okay, great. Thank you.
If you only do this, you get 42, but that's not right because you have to do it 2 more times. Now, real quick, earlier I promised you a bit of a shortcut. Watch this. So if I put 1 foot is 12 inches, that means that 1 cubic foot is 12 cubic inches. You don't have to do this if you don't like, but this is a bit of a shortcut. So you don't have to write this 3 times. Then in your calculator, you would say 3.5 times 12 to the 3rd power. You're going to get the exact same answer because you're multiplying by 12 3 times. So that's a bit of a quicker way to do it if you like it. If you don't like that, do it like this. Mathematically, they're the same. Okay. I see the question in chat. I'm trying to work my way towards it. Okay, somebody likes it. That's good. Everybody else hates it. I'm sorry. All right, so page 87. Oh, that's perfect. I'm on page 87. Number 69. Let's see. In 2015, there were approximately 3,998,000. Wait a minute. What are they doing? Okay. I'm pretty sure that's a typo. That has got to be a typo. What are they doing? Because there's no way. All right. Is everybody able to look at number 69? Let me share this. I don't know if this is part of the question. Oh, you got to love it when a book has a typo. You're like, come on, this is hard enough already, book.
I got the
I-
first part, couldn't get the second part.
Do you see where the typo is? This typo might be right here. 3,998,000 million bursts. I mean, that doesn't make sense. That would be
Oh my gosh, it's true, yeah.
398,000 times a million. So that's saying that there's more babies born a year than there are people. All right, I don't want to consider the implications of that. All right. Somebody is there's a lot of kids going to hold it. All right. So I don't know if you just kind of overlooked that. I think the book didn't even realize what they did because it is 3,998,000, but that million shouldn't be there. All right. So assuming, just take that word million out. That's the typo in the book.
It was hard for me and I didn't even notice the typo, so.
Gotcha. Okay. So find the birth rate in units of births per minute. So what is the units to begin with? 3,998 watts per what? You can do it. 3,998,000 watts births, right?
Was per
Per
year? Because that was
year.
in 2015.
Because it's just 1 year. Births.
Can I see your
Year.
screen? Can we see your screen? Or,
Oh, sorry.
or not the book, please,
All
thank
right, all
you.
right. Thank you. Just
Thank you.
I really, really, really never wanted to be an online teacher. I think I told you that already. So anytime I'm doing something like that, just remind me. Sorry. All right, camera. Do whatever you want to do. Is everybody cool with that? That's what they give me. And now I forgot. They want you to take that to how many bursts per minute. So what unit is not correct based on what they want? What unit is currently not what they want?
The 1 year? I mean,
Year.
that's not
They don't
even
want
a-
per year, they want per minute. So let me write this over here. All right, now I really want you to see. I mean, this is so beautiful. This is so. I know. I'm the weirdest person in the room, even though we're not in a room. But I think this is beautiful, and I don't mean the miracle of birth. I mean this problem. You identify the unit or units that are not what they want, that they want you to convert. So I don't want the years. So where am I going to put years? Here. So I get rid of them. I don't want years anymore, do I? I want minutes. So where am I going to put years?
The top.
Bottom,
Where do I put it so it cancels with this?
On the top.
next,
On the top. And also we have our little path. Where can I go? Years to what? Let me help you guys out. Don't do months, because every month has a different number of days. So that's not a good way to go. Years to days. Assuming it's not a leap year. Holy shit, right? Years to days to hours to minutes, right? I think it was minutes I wanted. All right, so there's a couple things going on. There's a unit I want to change. So I got to figure out the path. Then the beauty of this is you just put the unit where it's going to cancel and you put where the next step is on the other piece. So like year goes there because I want to kill it. And now I can go to days. Then I can fill in the numbers. Right? So you don't have to guess where 365 goes. Where do you know it goes?
With days.
Yeah. And up here's a 1. And then you keep going. I'm not in the right unit yet. So where am I going to put days?
On the top.
On the top. So it dies. Die days. And I want to go to hours. So then 24 hours in a day. Now keep going. I'm not going to do the whole problem for you. No.
I think I messed up because I did months.
Yeah, the reason months doesn't work because they don't have a set number of days per month.
Okay, yeah. Thank
Right.
you.
And us math people kind of look at that and go, come on. But it's too bad. I know banks will certainly do some calculations based on 30 months in a day, 30 days in a month, right? But that's not good because it doesn't come out right. It comes out to 360 days in a year, and there's 5 days that are gone. And in 2020, there were at least 5 days I'd love to forget, but oh well, can't do that. Is that all right, guys? Is that? So the idea of how to convert units does not change. The units I have to convert changes, of course, but the idea of how to set this up, put the unit where it's going to go to die, and then you go from this to the next step. Unit where it's going to die, go from this to the next step. You keep going until you're where they want you to be. How do you know you're going to be right is if minutes ends up on the bottom, because it's supposed to be bursts per minute. So if minutes are on the top somewhere, you're wrong, right? So that's, again, it's just, that's another check to make sure that you've done things correctly. That, again, is another piece of unit analysis. Are your units coming out correctly at the end? All right. Is that, I guess that's okay. I think the
Yeah,
person
that's
who
great.
asked it-
There's a part 2 question in there as well.
Oh, shit. Let me see.
Thank you.
Oh, all right. So the part B, assuming a U.S. population of 321 million, what was the annual birth rate in units of birth per 1,000 people? Now, this is neat. All right. Let me see. Let me do an example like this with a little bit better numbers, right? Just so you can see what to possibly do here. And I, this is what they do with COVID, for example, is you want to talk about number of cases. They actually do it per million people. So then you can compare states. It's not fair to say California had the most cases. Well, California has the most people. So that's not fair then. You have to compare it per capita, which is something that certain politicians don't quite get. But oh well. Let me see, what was I talking about? So if there were, let's see, 5,000 hot dogs, and there are, let's see, 260 people. How many hot dogs per 100 people are there? So the most direct way to do this, let me see if this makes sense. If there are 260 people, how many hundreds of people are there?
2.
Almost.
2.6.
2.6. So there are currently I've got 5,000 hot dogs per 2,600 people. I really want you guys to understand it. And hidden in what we just said down here. Is everybody cool with that? I mean, what is a little side note? What the shit does 3.7 million people mean? What does 3.7 million mean?
3,700,000.
Yes, 3 million. And then the next thing is 700,000. So what does 2.600 mean? 260. That's exactly what that is. So look at the problem and what it asks you in the book. It says per 1,000 people. So then when you want to write the number of people in terms of thousands, and what's the shortcut for that? To finish this out, you would just divide these and you would be done. If you divide these, you're done. Whatever the hell this is. I picked really kind of gross numbers, so too bad for everybody. 2 3/5, 13 fifths, 5/13. Somebody help me. I'm trying to do it in my head. Somebody needs to stop me.
I got 1,923.076.
You see that? Yeah, that makes sense. Yeah. Hot dogs per 100 people. All right. I like it. Oh, thank you, Alejandro. I didn't see that. What was I about to do? I forgot. Oh, yeah. So let me give you a different, like if I said there were 4,980,000 people, I'm sorry, let's do just 4,980,000. How many thousands is that?
$900.
Oh, I see what you're saying. Not what number is in the thousands place, which would actually be 0. What is 4 thousands? What number would that be? 4 thousands. Would it just be 4,000? Right? So 4,000 is how many thousands? 4. That's easy. 54,000 is how many thousands?
5.4.
No,
54.
54.
Oh,
Do you see it? Because 54,000. So how many thousands is it? 54.
So that's 4,980,000.
Yes. Here's the thousands, right? So how many thousands is this? It's this many thousands. 4,980. So I mean that's the quickest way to do that problem. I could show you another way to do that problem. Yeah, I mean here's another way to do that problem. This is the most direct way to do it. And before I do it, let me ask you this: how many millions is this? Exactly.
4.9 million.
4.98. Yeah. All right, now, if I want to do this problem again, 5,000 hot dogs and 260 people, I could do 5,000 divided by 260, and they want it per 100, so I can actually just multiply this by 100. So that's another way to do this for anything. So if they want it per 1,000, you can divide the two numbers and then multiply it by 1,000. Right. That way, I think more of you guys will probably like this way, but it kind of loses the idea of why it makes sense. But still, you're like, I just want to get the problems done, Jeff. All right, all right.
So even though we can do it in 2 different ways, it would behoove us to do it in the way where the second number, so the 260 is made as a decimal, or
you do it either way you want to. Just the other way, you can see the idea happening, but this way still works. I mean, if you reduced this and this, when you still get 2.6, just like we got earlier. Do you have to see that? No, but I'm just showing you mathematically they're the same way. Okay. Maybe. So in general, if you want to, if they say, what is it per 10,000 people, you can just divide the numbers, multiply by 10,000. That'll work. That'll accomplish the same math. Mathematically, they're equivalent, but the idea is lost a bit in the second way. But still, mathematically, they're equivalent, so math doesn't care. Okay. Anything else, guys? Did I miss anything? Okay. So before we keep going, any other questions? I updated the homework sheet. Let me show you this real quick. I didn't really change any homework. So if you're hoping I cut back on the homework, that's a good hope, but it's never going to be true. Let me show you this real quick. Get out of there. Bam. Scheisse. No, I don't want Microsoft Play Store. All right. Share screen. Bam. All right. So if you go to homework, all I've done is put Martin Luther King Jr. holiday on there and also put the last day to drop as the 15th. And I updated section 2C as extra credit in case you weren't there last time, last time. Let me think, what else did I do? Did I do anything else? I'm thinking about this. Let's have a discussion about this real quick. What's happening on January 20th? Nobody knows. Does anyone know what's happening January 20th?
The inauguration.
Inauguration.
Nothing else.
Sorry?
The inauguration and hopefully nothing else.
Very good. Very well said. I kind of want to see it as it happens. So I'm considering doing two things. Do you guys notice how the 19th was going to be the midterm and there was not going to be any lecture? We were just going to take the midterm during class. Are you guys with me? Are you guys with me?
Yeah.
Okay. Yeah. I'm considering putting the midterm on the 20th, but making it so that you can take it on your own time, so that effectively we get the 20th off. You can do the midterm on your own time, and there would be a time that you have to turn it in. And when you start it, it's a certain amount of time you have to do it. Are you guys with me? Just the way the first quiz worked, it just wouldn't be during class. I was already assuming there was going to be a day that no lecture happened, so I could actually make it the 20th when that happens. Nikki, what's up?
So then essentially we'd have no actual class on the 18th and the 20th.
That's right, because currently we would not really have class on the 18th and the 19th, because the 19th would be devoted to taking the midterm.
So, okay.
So it's the same situation. It's just that instead of the midterm happening during class time, it will happen during whatever time you want up until a certain due time. So I would make it, so let's talk about it this way. This next quiz that's happening tomorrow, the way it's going to work is at the end of class, the quiz will become accessible. And then you have from the end of class until probably the next morning to do it, right? And once you start it, a timer will start. So you have about 24 hours to start it, but when you start it, you have so much time to finish it. That's how the second quiz is going to work. And actually, that's how every quiz is going to work. What I'm doing is I'm making the midterm work the same way. Because I think it's an important day. I think I echo Ian's concern. That's I just want to watch it as it happens, because it is an important thing, and I want to be, because otherwise I'll be teaching and also keeping an eye on whatever thing I have open, showing me what's going on. And if a lot of excessively horrible things happen, it will be very difficult to concentrate on just teaching.
So could you repeat that schedule again, the 18th, 19th, and the 20th, how that would work, please?
18th is a holiday, right? No matter, nothing I could do about that. I want to make it so that the 19th becomes a normal class day. And I'm going to make the midterm on the 20th, but it won't be during class time. Actually, to be honest, all right, I really want you guys. All right, somebody's with me. So I would have office hours from 8 to 9 on the 20th. And you can come in, you can ask questions about the midterm. You can ask questions about homework, whatever. You can ask questions about the quiz that we're going to have on the 14th, right? That I'll have graded. And then at 9 a.m., I'll open the quiz. I'm sorry, the midterm on the 20th. I'll open the midterm. And then you have from 9 a.m. on the 20th until probably 7 a.m. on the 21st to actually take the midterm. So you could take the midterm during class time, especially if that's the only time you have to take it. Right? I kind of would rather you watch the historic inauguration, but that's not something you have to do. Right? You can take the midterm during that time. Are you guys at all with me?
Yeah, I follow.
Okay. So this is not completely selfish. I mean, I think this is considering a lot of things. This is going to be kind of historic.
So
Yes.
what I'm wondering is what you were going to, you didn't have a plan for holiday day, I'm assuming for, a lecture.
Of course,
Because
you can't.
already on the
That would-
schedule, right?
You
So
all could rise up in insurrection. You could remove me if I try to
what
schedule a
was,
lecture on a holiday. Yeah.
what were you going to be teaching on the 20th?
Whatever I was going to be teaching on the 20th, I'll be
Yes.
teaching on the 19th now.
On the 19th, okay.
Yes. And in
I get
fact,
it.
we can have part of the 19th devoted to some midterm review now, right? All right. The minute I say that, I think I've won everybody over, but not all of class time. Don't get too excited. We got stuff to do, but so effectively, we're not going to lose any lecture time
Mhm.
doing
Yeah,
this.
okay.
So that's why I feel okay requesting this. If anybody has an objection, you're fine. And if you don't feel like saying it out loud, you can just privately chat it to me, because this is a change in the time frame. And I want to make sure there's no objections to it before I make it official. Okay. All right. Yeah. Considering anyway, that's good. Okay. So just let me know if you're still not clear about something. You can stay after class or something or whatever if you're not sure what's happening. So I'll update this and post the new one up here, so you're all clear on what's happening. Okay.
I just need a reminder, our corrections and quizzes and homework need to be turned in by the final, right?
Day of the
But we
final.
want to get them in before because it'll help us for the midterm and all that. Okay.
Yeah, those are exactly. And this is stuff that you consider for yourself, right? This is where you
Okay.
take control of the course for yourself. You're like, what's more important? If you're not done with the homework itself that the midterm will cover, you want to do those sections you're not done with. If you do complete those, then you start to consider, let me maybe make some corrections on quizzes or homework, right?
Yes.
That's why I like to give you into the final for corrections, because the most important thing is new stuff.
Yes.
Yes.
Okay. Great. Thank you.
You're welcome. Okay. Anything else before we transition back into, we're going to get into chapter 3 now. Because yes.
Just one quick question. The test tomorrow is going to be primarily on chapter 2, right?
The quiz tomorrow is all 2. So it's 2A, 2B. That's all it is.
Okay.
Yep.
Thank you.
Any homework that you guys turn in from chapter 2 today, I'm going to try to grade throughout the day. I was ready to do that over the weekend. I had one person turn in 2A. I graded that. So I'm going to try to grade whatever you guys turn in before class tomorrow. I'm going to try to get it graded so you have it to look at. Okay.
I'd like to ask, is there anybody would anybody want to form a study group? Because I have the problem where I can stay today. I'm going to be staying for tutoring, but I cannot on Tuesday, Wednesday, and Thursday. So either I join a study group, or if not, I just need to get a personal, hire a tutor on my own.
I was considering, how many people did I have come to that? I had that hour, that office hour, 3:30 to 4:30 last, whatever day it was. How many people would be able to come 3:30 to 4:30 on whatever day?
Oh, I'd be here today. I'll be here today. And
Well,
yeah,
I'm
all
gonna
week.
figure out what's a good day to do that.
Every day is good for me, 3:30 to 4:30. I need help. I want to make sure I get it.
All right, so let's, maybe it'll be a weekly thing that I can set a schedule. So this week, let me see. Yeah, so like it makes sense to do a session today because we have the quiz tomorrow. And then a session on the 13th because then we have a quiz on the 14th. Right, so like so Monday and Wednesday this week, I could do a 3:30 to 4:30 office hour. Is that cool?
Okay, Monday and Wednesday.
Shit, and I gotta remind myself. You gotta not, somebody email me right now.
Monday and Wednesday.
Monday, Wednesday, 3:30, 4:30. Jeff, make that Zoom time, please. Thank you. Something
Okay.
along those lines, or else it's gonna be gone the minute I start talking about other things. Okay. I was absent-minded even when I was in my teens, so it's just getting worse and worse. You're like, oh, that makes me feel confident being in your class, absent-minded boy. I'm like, be quiet. Okay, so woo, let's get into math stuff. We're going to get into chapter 3, and I want to discuss some basic ideas. I have a handout up on Canvas that I want you guys to work on, and we'll see how far we get. And let me see. Let me do this. I'll discuss a bit. We'll take a break. Then we'll do group work, and then we'll finish up as much as we can, and then we'll call it a day. So we're about to get into a topic that confuses so many people, and so many people know that. There are many people that understand that percentages confuse the shit out of people, so they constantly say things that are technically true, that make people feel a certain way, but mathematically they don't make the most sense. So we're going to sort of get the basic idea of what a percentage is, slowly work our way up into different ways to use them, and then start to look at possible ways that people can mislead other people. So, thank you, Nancy. All right. With me. Percentage. When I say percentage, does anyone have anything come to mind? Anybody?
Per 100.
Okay, I like it. I like it. So we're going to start with a very good place. We're going to start at what the hell that actually means. The word percent does translate directly into per 100. The mistake people make is somehow they think there's always 100 people or things. No. So if 5% of people in a room like green beans, green beans are yummy. Oh, well, these people are crazy. If 5% of people in a room like green beans, and there are 600 people in the room. Actually, let me start off with this. What if there are 100 people in the room? How many people like green beans? So what is 5? Sorry.
5.
Yeah, what does 5% mean? And what's really kind of weird about the percent symbol is, do you see how it's the number 100 switched around? Take
Oh
the
my
1,
gosh,
take
that's so
the 0.
true.
Yeah.
Oh,
All right, so that's neat. Is that really the history of it? I don't think so, but we'll go with that. So anyway, 5% means 5 per 100. So for every 100 people, 5 would do this. So if I have 100 people, then obviously 5 like green beans. I like green beans. All right. So if I had 600 people in the room, how many like green beans?
30.
How do you know that? Yeah, if one way you can do this is 5% means 5 per 100. So what would that be per 600 times 6 times 6? 30 per 600. So 30 people would like green beans. No. This is not the way we normally do it computationally, because we don't normally have such nice numbers, right? We have 5 and 6, 100. I mean, those are nice numbers. So mathematically, what would I actually do? How would I actually do part B more directly mathematically? So I would do 5% of people in a room like green beans. Well, how many people in a room in part B? 600. All right, let me stop for a minute. So this is one of the first big things, is what the shit does of mean? Mathematically, what does of mean? Everybody used to know.
Multiplication.
Yes, it means multiplication. So the very first basic skill with percentages that we have to know is what number is this? This is not a number. This is a percentage. What number does it represent? Well, how do you write 5/100ths as a decimal?
0.05.
All right, and we've talked about that before, right? We've talked about the places after the decimal point, so that'd be 0.05. So 5% of 600 directly translates into 0.05 times 600. That's exactly what that means. And if we don't get 30, we can throw this whole damn thing out, because we already got this answer. We already know it's 30 people. So math better get the same damn answer. And thankfully, what is 0.05 times 600?
30.
30. And here's our cool trick. A little side note. If I move this decimal once, twice, and I move this back once, twice, 5 times 6 is 30. Bam! You could do that all the time with decimals. I have no idea. It's a musical day for me. I don't know. All right. Now, some of you guys know some of the stuff I'm throwing at you. Some of you guys, it sounds a little familiar, right? Hopefully this is very familiar. This is a very classic kind of problem here. Okay. All right. Let me see. I'm trying to figure out which way I want to go with this. Yeah, let's just keep going down this path for right now. So how would I do this? Let me see. Here, you guys try a problem out real quick. I'll make this part B, like that was part A. What is 11.2% of 7,987? You're like, math teacher. Thank you, math teacher. You do the easy one together, and the hard ass one, you leave it to us. Oh well, too bad. So the
Is it 894.544?
sounds about right. Let's all catch up to you. The key thing here is, how do I convert that into a decimal? So how do I always convert percentages to decimals?
You move the decimal point to the left twice.
Yes, because when I divide by 10, the decimal moves back once. It gets a factor of 10 smaller. Percent is dividing by 100, 2 tens. So of course I'm going to move this back once, twice. So this will be 0.112. Of means times. And then of course, whatever the hell that is. So that's why it sounds about right. 840 something.
894.544.
That's probably exactly it, right? Okay. How's everybody doing? Does this sound familiar? Does this okay so far? If it's not, let me know. So let's do this. Let's focus just on this. So I like to give a problem like this. What do you got, Jeff? Fraction, decimal, percent. Right. So if I had 7%, what would that be as a decimal?
0.70. I meant 0.07.
Good. 0.07. You got to take the decimal of it once, twice. So once, twice. Why? Because percent means divide by 100. Here's something really cool. D, P in alphabetical order. If I want to go from a decimal to percent, I move it that way. If I want to go from percent to a decimal, I move it that way. So from percent to decimal, I move it back once, twice. Again, twice because that means 100. Back or forth because here I'm dividing by 100. It's getting smaller. So the percent number will always be bigger than the decimal number because this one hasn't been divided yet. So there's always two levels. There's the shortcut. All right, I know which way to move it. And then there's why the shit you do that, right? So too many teachers don't get to the why as much as they should. But now, what is this as a fraction? Why is the fraction easy now? Two reasons. I mean, what is 7%?
7 100ths.
Yeah, because that's what percent means. But also this is tenths, hundredths. Kick ass. So let's see. What about 0.043? What is that as a percent?
4.3%.
Yeah, because now I'm going to move it once, twice that way. Now here's where things get interesting. What's the fraction answer for this?
43 over 1,000.
Yes. Tenths, hundreds, thousands. 43 over 1,000. Stay with me now. Stay with me. Some of you guys are like, oh, good, numbers, yay, not these freaky ass logical definition bullshit. And then you're like, numbers. Oh, yeah, I'm bored as shit. No, stay with me. Stay with me. This is neat. Watch this. Watch this. What does percent mean again?
Per 100.
Per 100. So
Yes.
you could say 4.3 over 100. That's wrong, though. Why is that not a fraction?
Because you still have a decimal.
Exactly. Fractions are defined to be ratios of whole numbers. So watch this. If I move the top over once, I move the bottom over once, 43 over 1,000, same answer. Yay, done. Woohoo, woohoo. All right.
I'm sorry, can you repeat that part again right there? About where you move it? You have 43, just that
Sure.
part right there.
So
That's right.
4.3% by definition is 4.3 per 100 because that's what percent is. If I multiply the top by 10 and the bottom by 10, now it's a true fraction because there's no decimals in it. Right.
Okay.
See this? Originally, it was like deciception. Right? There's a decimal inside my fraction. So then if I multiply top and bottom by 10, I just want to show you that you get the same exact answer from this as you do from this because it has to be, right? Should work any way you look at it. Okay. All right. So there's that. What if I had this? What if I had what do you got, Jeff? You could do it, buddy. There's something. You're writing something. There you go. Okay. What if I had 7/20ths? Can you convert that to a decimal and a percentage? If you had to do this by hand, what would you do? By hand.
Is it 35%?
How do you get that?
Because you have to multiply 20 by 5 to make it
Good.
100.
If I can make the bottom out of 100, and to be honest, out of any number, multiple of 10. So if I multiply top by 5 and the bottom by 5, I get 35 hundredths, which is 35%, which is 0.35. And of course, if you can't make the bottom become 10 or 100 or 1,000 or something, you just have to divide these, right? If you do 7 divided by 20 in your calculator, you get 0.35, right? Okay. So that's one level of skill. It's just how do these guys interact? How do you convert between these different versions of things? All right. The next level of skill really is this. How do you work with a computation question like this? Let me see. Let me keep myself on track. Oh yeah. Okay. What about this? All right. Let me take this away. Here it goes. Everybody ready? Here it goes. Okay. Are there anybody here left-handed? Can you indicate to me somehow? Let me see. 1, 2. Okay. 2, 3. Okay. The voting has closed. And there's 15 people here. Can somebody tell me what percentage of the people in here currently are left-handed? I am not left-handed.
How many are we? How many people?
3
5?
people said they were left-handed, and there are
5?
15. No, there are
20%.
15. Huh?
20%?
How do you get that? Not.
Wait,
You can do it. Tell me.
If
How do you
we're,
get it?
we're 15 people
15 total people,
and 3 left-handed.
and there are 3 people that are left-handed. So that's the right answer. I just want to know how you got it. I'm curious.
I was right.
Yeah.
Rule of three.
I don't know. I just do this stuff in my head. I don't know how.
Oh shit.
Oh.
You did something. I know you did something. You got the 2, and then you sort of, I think maybe you just got the 2, maybe. I don't know. So what is the way you set up the ratio here? How many out of how many? How would you say this in English? 3 people are left-handed out of,
3 out of 15.
wouldn't we all say it like that? Isn't that an acceptable way to say that in human English? Yes. Okay. So 3 out of 15, which mathematically, of course, is 3 out of 15. Is that? This one's a very nice fraction because what's one thing you could do immediately with this?
Divide.
Divide. Or, reduce. I'm going to assume that's what you meant. And then you can make that out of 100, right? Or you can actually just divide this to begin with, get 0.2. Or you can do this like we did a second ago. %. Cool. I like it. Okay. So that's a huge thing for me is how do you just create basic percentages? So this is part out of whole. Could this kind of problem ever be greater than 100%? Could you do this kind of problem and get more than 100%? No, that would be neat. That would be like that shirt that says 4 out of 3 people have trouble with fractions. Right. So I have a group of 3 people and 4 of them have trouble with fractions. Like I have created a person. Ah. Okay. But can percentages be bigger than 100% and actually mean something real? In general, yes, of course they can. Of course they can. So this kind of problem is a of problem. 3 out of 15. So it's a per problem. It can never be more than 100% because it's talking about a part of a whole. So what kind of problem, here's the last idea we'll talk about and then we'll take a break. What kind of problem could be greater than 100% and still make sense? Not the kind of problem we just did. That can never be true, but what kind of problem could do this?
What's the percent increase?
Sure, yeah, exactly. It's like I planted you. That'll be the next thing we talk about is the idea of percent increase, or actually more generally percent change, right? Because it could increase or decrease. So you could have negative percentages make sense. You could have 10,000% make sense if you're talking about how much something increased. Right, let me ask you this question, then we'll take a break. If something doubles, what percent more is it than it used to be?
100%.
100% more. Beautiful. So if 7 doubles and becomes 14, isn't that 7 more than it used to be? Isn't it 100% of what it was added on top? That would be 100% more. That would be a 100% increase, means double. So a 200% increase means
Triple.
triple. Okay, that's enough. Let's take a break. You guys want you want a 20-minute break? You want a nice
Sure.
break? That way we don't take another break and we maybe leave a little early. Let's see. So what time is it now? 10:15. Perfect. So you come back at 10:35 and I'll start then. And if you have a question right now, let me know. Hold on to your butts. All right, let's see. Let me show you what I've been up to during the break. Hold on. Where'd you guys go? There you are. So if you go on Canvas right now, I think I'll do this every week. I'll just update this very first module. So if you go to your modules, the very first module, I'll just update it every week with whatever the office hours will be that week, right? The extra office hours. I always have my 8 to 9, right? 8 to 9 before every class. I'm here on Zoom, sometimes very lonely. And then I'll also have sometimes 3:30 to 4:30. So this week, if you click here, that's the link that'll work for today's extra office hours and Wednesday's extra office hours. I like it. Please don't click on the link for class because that won't work. That'll take you to a non-existent Zoom meeting. So don't
Sorry,
do
where is that link at again?
If you click on modules, it's the very first module.
Oh, okay, great, thank you.
Kabam. Next thing, just to show you this, we're not quite ready for this yet, but if you go down in the modules to unit 2, I'm sorry, we're now in unit 3. There's a percent practice sheet that we're going to work on here in a minute. So just maybe get that printed out if you want to or whatever. I do want to say a couple more things and then we'll do this sheet. Let me just remember what it was I wanted to say. You can do it, Jeff. Give me just a second. Where did I put this here? Oh, the hills are alive. Let's see. Oh yeah, okay. Do I need to say that? Yeah, let's do that. Let's do one example like that, and then I'll unleash you on this thing. So, did I make a thinking face? I like that. All right. Come here. Come on. All right. Let me see. Is that too close? So let's do one more example let's do two. Let me just lie immediately. Let's do two more examples. So let's see, based on what we just did right before the break, how would you do this? What is 9% of 500?
Uh, 45.
Yeah. So so there's actually several ways to do this, but the most direct way is 9% is what as a decimal?
0.09.
0.09. Of means times. And then you can do the little trick if you want to that I showed you, or you just plug in the old calculator. Any way you do it, you get 45. All right. Another way to do it real quick. 9% is 9 over 100, right? Of means times 500. 100 goes into 500 5 times. 5 times 9 is 45. Mathematically, I just did the same thing. That's why I get the same answer. Okay. I'm just showing you another way. I mean, either way works. Either way works.
What is it that you were doing there? What is 9% of 500?
Yes.
Oh, I see. Okay, got it.
So 9% of times, or you could do 9 over 100 is what 9% is, times 500, and then you can reduce. Mathematically, they're both the same. You can do it either way you want to. All right. So what about this? This is a little bit different. 11 is what percent of 30? There are many different ways to do this. Some of them are remarkably silly. Here's the most direct way to do this. 11 is, what is that mathematically? What is that mathematically? What does is mean in math?
Equals.
Equals. 11 is what percent? I don't know. So what would I put mathematically? What would I put there?
X or
X.
any other
Anytime
letter.
I don't know something, I love it. What percent of times 30? So you can directly translate any statement that is in this form. Something is something percent of something. You can translate that directly into algebra. And then, oh shit. Some of you guys are like, I don't want to translate it to algebra. How do you solve this equation for x? How do you get x by itself? How do you kill the 30?
By dividing the whole thing by 30?
Yes. Some of you guys froze. Okay. All right. I think I've lost somebody. Okay. Divide by 30. Divide by 30. Some of you guys know is over of, right? 11 over 30. Does that sound familiar? I kind of personally dislike that, but it doesn't mean you can't do it. That's fine mathematically. So let's see what we get. 11 divided by 30. Does somebody have that for me roughly?
My calculator might miss that second. 0.366.
Is the sixes repeating or something?
There's a whole bunch of them, and then it turns into a 7 after like 6 or 7 sixes.
So it rounds. So then percent would be once, twice, 36.6 repeating percent. So you can take this form of question, translate it directly into an equation. 11 is what percent of means times 30. And then you just solve. Okay, maybe. So let's try this. I think everybody is able to access Canvas right now. So go to Canvas and grab that percent practice sheet. Let me show you again where it was. Let me see if I can move my big old head out the way. There we go. So if you go to Canvas, oh shit, where are you, Canvas? Canvas, you're gone. Let me try this again. There you are. Go to modules.
These really help a lot.
Thank you. Or you're welcome. I guess they both work. Go to percent practice.
You're welcome.
Go to percent practice. And then go ahead and work on this. You don't have to print it out if you don't want to. I'm going to let you work on this alone for a little bit. Then I'm going to put you into groups and then we'll do it together. And then whatever time we have left, we'll get a little further into chapter 3. So we did a problem like this at the top. I love this kind of problem for very basic percent and fraction stuff. And this is the kind of thing we just did. I'll give you a couple examples of that here. Let me know if you can't access Canvas right now. So everybody should be working on this sheet. So I'm going to stop sharing because I'm evil. And we'll see if anybody says anything. I'm going to stop recording. So let's take a look.
I'm sorry, did you record when we came back from lunch?
Came back from, oh, the break earlier.
No,
Yes.
I'm sorry, break.
Yeah.
Awesome.
All right, so you guys can see the sheet now, right? Just to make sure okay.
Yeah.
So,
Yeah.
all right, so look here. I know there's some that gave people a little bit of trouble. So we're gonna look at them a few different ways to make sure that makes complete sense. Does somebody want to tell me how they did this first one?
So I divided 3 by 5,
Sure.
and then that gives you the decimal,
Okay.
which would be 0.6.
Yeah, that was a nice quick one. Or you could multiply top and bottom by 2 and get 6/10, which will be 0.6 also. So either way is about same amount of time. I like it. And then of course, to make that into a percent,
You move the decimal to the right twice.
good. So this will be 60%. So if I do 3/5 of something, that is the same thing as 60% of that thing. Where am I? There I am. All right. Now this, so I think the first row should have probably went pretty well. What about the second row? That one's not too evil. Somebody else tell me, how do I get that from a percent to a decimal?
You move the decimal over 2 to the left to get 0.42.
To gas, 0.42. And now either way you look at it, it's going to be the same answer here for the fraction. This is in the tenths hundredths place. So it's 42 over 100. And of course, percent means over 100. So this says 42 over 100. And then you can reduce it. The funny thing is, I sometimes tell you don't reduce it because people know their fraction keys in the calculator, and that always gives it in reduced form. So sometimes I'll say, do not give it to me in reduced form, just because. All right, maybe. This next one is a little more gross, but it's still pretty straightforward, hopefully. Here's the way you look at this. It's determined by the place that the last number is in. In fact, how do you say this number? This number here. How do you say that?
97,000?
97,000.
Yeah, because the 7 is in the thousands place. I don't care that the 9 is in the 10,000s place. I'm going to say 97,000. I'm not going to say 97,10,000. That doesn't make any sense. Is that clear? So it's the last digit tells me what place the whole thing is in. Tenths, hundreds, thousands, 10,000ths, right? So the fraction will be 97 10,000ths. Done. Now as a percent, all I have to do is what? What do I do to the decimal? I just have to move it.
To the right.
Once, twice. So then I get 0.97%, less than 1%. I like it. One thing I'll only speak about briefly while it's in my brain. First thing about this topic is nobody knows what the true mortality rate of COVID is. So if anybody on Facebook or any crazy uncle or whatever claims to know what the mortality rate is, they don't have a clue what the shit they're talking about. No scientist on the planet knows what that is. The estimates are anywhere from 1 point something to 3% or something. If the death rate was 1%, do you know how many Americans that means would die if everybody got it? Do you know how many Americans there are currently? Roughly 330 million. So 1% would be 3.3 million people. So it kind of pisses me off when people are like, oh, you're scared of this thing and it's only at 1%. I'm like, that's over 3 million people. Sorry, I'll stop. I don't want to get too serious. All right. That's just one example. That's a huge one right now about misunderstandings of percentages. That's a huge one. This next one gave some people some trouble. So let's look at it a few different ways. To go to a decimal is pretty simple for percent. So let's do that first. How do I make this into a decimal? What do I always do?
Move to the left 2 times.
Once, twice. So this is 8.13, which makes complete sense because 100% is what as a decimal? 100% is if I ate 100% of a pizza, how much pizza did I have? I had one pizza.
One.
Yes. So 200% would be
2.
2. So 800 something percent should be 8 point something. That makes complete sense, right? 800% should be 8 point something. Now, give me a minute. I said I was going to look at this a few different ways. How would you make this into a fraction? What's the fractional part of this? What part of this is a truly fractional part?
The 13.
Yes, this is like a mixed number, isn't it? Wouldn't it be 8 and 13 hundredths? Now, a little group might be screaming at themselves saying, this guy came in my room and he said it was something different. No, you ready? What's another way to look at this? What does percent mean?
Of 100.
Out of 100. So it should be 813 out of 100. Are these two things the same? Shit, yeah. How do you convert from mixed number to improper? 100 times 8 plus 13. Bam. I don't care which way you put it. They're both correct. Is that better for anybody that had trouble with that problem? Or are you neutral? Did I make it worse? That's always the worst thing for me to do.
No, it's better.
Okay, thank you. I hate it when people, I understood it, and then you spoke a little more, and then I didn't. I'm like, damn it. I gotta know when to shut up. And then all of a sudden I take a swing back and I give you a nice easy problem. Should be easy. How do what's that as a fraction? Please let that be nice.
8 over 10.
Yeah, that's in the tens place. Easy shit. And what is that as a percent?
80%.
80%. Kick ass. I like it. And of course, I had to give you one that didn't quite flow too easy. So what do you have to do with 5/8?
You divide 5 by 8.
Yes, and here's the thing that I don't understand. I started realizing over the last like 2 years, maybe, I've seen more and more people say that this is this. Is that correct? Hell no. I don't know why that is. I don't know if part of the brain says 8 can't go into 5. It has to be the other way. No, we know this is less than 1. Of course, it's going to be weird when you do this. Right? I don't know if any, I didn't say you had to do this by hand, so I don't know if any intrepid souls out there did this by hand, but it would be 0.625. Is that right?
Yeah.
Yay, Jeff. So 0.625. And of course, what is that as a percent? That's nice.
62.5%.
2.5%. So the only real reason we completely made up the idea of percent is because I'd rather say 0.97% than 0.0097. I can get what this means because it's always based on a pi of 100. So if somebody said 1% of the budget is spent on this, I can see that better in my head, right? That's the only reason we made up percentages. And that's why we have to make them into decimals when I want to do math with them, because math requires the actual number. Okay, maybe. I didn't really mean to do this earlier. I forgot what example I had on here, but we basically did this problem earlier, right? What do I do with these numbers to get this?
3 divided by 20, and then move the
Yeah,
decimal point.
20. I like it. You can divide it, or you can multiply by 5 even and make it out of 100. Either way you do it, you get 15%. Kicking the ass in. All right. And then we got these bad boys. And again, if you have a different way you really like to do these than this kind of algebraic way, the is over of thing, whatever you got, if it works for you, you can do it. If I want to translate part A, what is, and what goes here?
0.45.
Yeah, 0.45 of means times 200. And that one's not too bad, right? You throw that in the old calculator. You get 90. Why does that make sense? What is half of 200? What's 50% of 200?
100.
100. So 45% of 200 should be a little less than 100. So 90 makes sense, right? Are any of you guys waiters, waitresses? If you are, I'm very sorry. This is a horrible time for you. I know. But at least California pays you. Doesn't California pay you like not a lower wage because you're tipped, right? Don't you get just straight up minimum wage?
I get taxed.
Other
for my
states.
tips.
Say again?
I get taxed for my tips.
Oh, shit.
Yeah.
I'm sorry. But at least you're not like another state that pays way below minimum wage because you're making tips, right? And of course, right now, you're probably not making anything. I'm sorry. But don't you wish people understood percentages better when it comes to your tip? But nowadays, I know most places already calculate the tip for people, correct? In fact, a lot of the receipts have, 15, 18, 20% options built in. But I want to show you something real quick. Watch this. If I wanted to do 15% of 60 by hand, let's say my meal came out to $60. Why is 10% easy to do? Can somebody tell me if I wanted to do 10% of something, why is that simple? How do you do 10% of anything?
It's an even number. It's 0.
So
That's why
help
it's
me out here.
easy.
Yeah. So what's 10% of 60 then?
6.
6. So really 10% of something is just dividing it by 10, which is always easy. You just move the decimal back once, right?
Yeah.
Now watch this. This is cool. If 10% of 60 is 6, what is 5% of 60?
3. 3.
3.
Cut it in half.
I don't know why I'm yelling at you guys. I'm sorry. I'm so excited.
3.
3. So then 15% of 60 would be 9.
So that's kind of a nice way to piece together percentages of things, right? Is to kind of build it. That's one way. Anyway, I just want to show you that real quick. Just how you can actually how flexible the idea of percentage is. How do you do part B? How does that translate?
So it'd be 72 equals what being the variable, so x, and then multiplied in parentheses by 135.
Kick ass. And then, of course, to solve for x, I just have to divide by 135. And those of you that like is over
Oh, I
of,
missed that. I missed that.
Sorry?
I missed
Sorry.
that part B.
What do you mean?
Tell us
Sorry.
what percent of
Were you-
80. Okay,
what happened?
I dropped my
What?
phone.
Oh, shit.
My phone and I missed part B. 12 is what percent of 180? Is that it right there?
No. That's the example.
Okay.
So part B is right here. 72 is, I don't know, percent of means times 135. And then, of course, to solve for x, I just divide by 135. And again, if you're an is over of person, there's your is over of happening right there, right? If you don't know what I mean by that, then fantastic. Just do it the way that I did it. And then x equals, what is this when you divide this weird thing? I don't know. I didn't do it yet.
0.533 repeating.
Neato. I said, so round to the nearest thousandths place. So 0.533.
Yes.
And then what would that be as a percent?
53.3%.
Okay. Is that cool, everybody?
What
happened?
Yeah, I'm laughing because I did it different and I was telling him I got a different number, but you got it, Don, right? Is that your name, Don?
Yeah.
Don, yeah, you had
Oh.
it. You knew your thing.
Does this make sense?
Well, of course, yeah, makes lots
Okay.
of sense.
All right. And do you see what went wrong with the other approach you tried? I'm not trying to pick on you, Nancy. I'm just saying in general.
Oh no, believe me, no, I can have you
Okay.
have all day long telling me because I need to learn. I need to get it.
Yeah.
So, okay, you know what I did wrong is I did 72 is I did 135 times 72% equals, and then John said, but remember it is of and all that. It is an
Yeah.
of and that. So he was doing exactly the way you had taught us.
Yes.
So
And so you do need a framework to make sure that you're multiplying, dividing, and things correctly, because otherwise you just kind of take the numbers and guess what to do with them. So this is my favorite framework, is just to take it. It is an equation just written in English. So we take the equation written in English and we translate it into Mathish, and then I can solve it. So that makes the most sense to me. Also, do you see, why does this answer make sense? Isn't 72 half of about 140? So then it should be a bigger percentage of 135. So the fact that it's a little more than half, a little more than 50% makes sense. So what about this? Let's analyze this before we actually do it. What would 5% of 100 be? That's a nice question. What is 5% of 100?
5.
5. I love it, right? Any percent of 100 is kick-ass easy, right? What's the square root of 7% of 100? Square root of 7, because it's based on 100, right? So 5% of 100 is 5. 5% of less than 100 would be 2. So it's a little less than 100. Okay. So I know the answer should definitely be less than 100. So let's see. If I translate this, 2 is, what is 5% as a decimal?
0.05.
Of means times, I don't know. And then I can divide by 0.05. So eventually you should get 40. So that makes sense. Okay, maybe. Maybe.
Sorry, can you repeat that again? Just so I can make sure I have that right. 2 is
Okay.
5% of what? 2 is 5% of what?
So 2 is equals 5% becomes 0.05. Of means times. I don't know. So that's going to be X. So how do I read this? 2 is 5% of something. So this is what the equation looks like in English, and this is what the equation looks like in Mathish. And then, of course, to get X by itself, I just divide by the 0.05 because that undoes the multiplication. And then I just throw that in the old calculator if you want to. Right.
That's what I don't understand. What are you dividing by what? 5, dividing 5 by,
All right, hold on.
dividing 0.05?
Let me do this. I'm possibly making a few assumptions here. So let me come back to here. So you're cool with the equation, right? 0.05x, right? 2 is 5% of means times, I don't know. So 2 equals 0.05x. Is that cool?
Yes.
Okay. Now, let me do a little side note down here. How would you solve this?
Oh gosh. You're gonna laugh. 4 times is it 32?
All right.
No, I don't know.
All right, listen. So even if you just kind of looked at it and didn't even do algebra, 4
Okay.
times what is it? That's really what it says, right?
2.
2. Okay, you know the answer should be 2. Now, algebra, what would the algebra do? I want to get X by itself, because if I get X by itself, then this is the answer, whatever number's on the other side. So this says 4 times X is 8. How do I cancel the 4? I divide by 4. Got to do it to both sides so I keep things equal. So then you do get 8 divided by 4 is 2. Is that, do you see that? So if I had, let's do something that's a little more disgusting. What if 7x equals 13? If I divide both sides by 7, why does this make sense? Because the whole question is, what the shit is X? So if I can rewrite this so X equals a number, I know the answer. That's why solving equations is all about getting X by itself, because then I know the answer. X equals this. So X equals whatever the hell 13 divided by 7 is. So what do I have here? Why is X not by itself? It's being multiplied by this crazy thing. So if I divide both sides by that crazy thing, I have X by itself. So then I know X equals whatever the hell that number is, which comes out to be 40. Okay. So I am going to assume, and again, I could do this every time this kind of comes up, but I am going to assume that we have some knowledge of solving equations from algebra, right? Because of the prereq for 120. But if it's been a long time, just remind me. We could do some examples like that when it comes up, just to remind you how that works. Is that cool, everybody? Is that all right, Nancy? Does that sound familiar at all?
Yeah.
Okay. So this, so that section there is one very basic form of working with percentages. Then we get one like number 2, which is a very common thing that we hear all the time. The percent increase or decrease in crime statistics and all that kind of stuff. If it was $4.99 and it fell by 18%, how am I going to determine what it is in 2010 now if it fell by 18%? What steps do I have to take to figure that out?
Would you multiply 499 times 18%?
Good. Multiply 499, not by 18, but by,
Or 18?
yeah, 18%, which is what decimal?
0.18.
0.18. So it is 18% of 499. But whatever that is that the answer?
No.
No. So what is 499 times 0.18? I think you get something a little gross, but it should be easy to round it. Yeah, not too bad. What do you get?
89.82.
Yeah. So if you round it, it comes out to 90. We're talking about people here or crimes, right? So you're not going to say somebody committed half of a crime, not technically, right? So pretty cool with this so far. Why is that not the answer? Why is it not? Well, there were 90 crimes in 2010. Good job. Because what do I have to do now?
You have to find the difference of.
Yeah. So it was
499.
499. It changed by this much. Missed it by this much. So now it should be 409 in 2010. That feels a lot like if a shirt is on sale for 20% off. You don't just take 20% and go, oh, wow, that's cheap. No, you take 20% and then subtract it, right? Now, real quick, is everybody at least okay with that? Are you guys any big questions on what we just did there? This is very similar to sale price, discounts. It's the same idea.
Yeah,
What was
I
that?
tripped myself up doing this because I did 0.18 over 499 and then try to multiply that by 100.
Whoa. Okay.
Yeah, I was
So
trying
really,
to do
if you wanna,
a decrease.
yeah, if you want to reword this, it would be what is 18% of 499, right? That's the first step. And that leads to this work. 18% of 499. Now you could do this problem in sort of one step. And if you don't quite get this, it's okay, obviously. If something falls by 18%, what percent is left?
82.
If you do 82% of 499, what do you get?
409.18.
409.18. If you round that, you get 409. Same answer. So that's how those kind of work. If something's on sale for 10% off, that means that it will be 90% of the price it used to be. Does that make sense?
Yes.
Number 3 is a little different. Number 3 is a little more direct. I put it on sale for 85% of its original price, not 85% less than its original price, but just 85% of its original price. That's a one-step problem now. What would you do to figure that out?
Multiply 1200 by 85.
Yeah, multiply 1200 by not 85, but what? Sorry?
0.85?
Kick ass. What is that? 170 times 6. So that's. Don't make me do this. I'm at 10,200. What is it?
1020.
1,020? That makes more sense. I don't know what I'm trying to do in my head. I got to stop trying to do it in my head all the time. That makes sense because it's less than it was. Okay, I like it. All right. If you have other ways to do any of these problems and you come out with the same answer, you can always just double check with me and say, is this okay what I did? Because sometimes it's just kind of lucky that you got the same answer. But, you know, if you got a different way that works, I'll let you know. Let's see. All right, there's one last thing I want to do, and then I'll let us out of here. Where'd it go? Oh, yeah, that's right. So let me bring us back. Is any questions on this sheet here? Okay. Last thing for today, guys. It's just about time to go. Shit. Let's see, where am I? There I am. Oh, I'm not even there anymore. Let me highlight myself. Yay.
Professor, I have a question. Would it be possible to share your worksheet with us? Your notes?
Oh, the one I just did with the answers?
Yeah, with all the scribbles and everything?
Yeah. Shoot me another email.
Believe it or not, yeah.
Let me see. I'll save it right now. If you shoot me another email, I'll post it.
Okay.
Okay. Bam. All right. Let me see where to go. There you are. Okay. So last thing for today. There's an idea called percent change, which is basically a couple of specific examples of percent change is a discount or a markup. So what gets interesting about percent change is this. If 400 people came, let's say attended last year, and get out of there. 480 people attended this year. What was the percent change in attendance? So let me ask you this. Let me show you how this makes complete sense. If I wanted to know what percent of you guys were left-handed, we did this earlier, how would I figure out what percent is left-handed? What do I have to know first? If I want to know the percent of people that are left-handed, I have to know what?
The total amount of people.
Total amount of people.
How many are left-handed?
Beautiful. So percent blank, I have to know the number that is blank divided by the total, right? So to do percent change, I have to know how much did it change by. So percent change equals the change divided by the original. That's the key. This is the mistake people make all the time. So how much did it change by? How much did the attendance change?
80.
How much? 80 people there. And what was the original number of people?
480.
No.
Oh, no, 400.
Yes, the original was 400. And then you can figure out what percent that is, right? What percent is that?
20.
Yeah, 20%. You whatever way you want to do it, 20%. What if it was turned around? So what if it was 480 last year, 400 now? What would the percent change be? Would it be the same? The change is still 80. But what was the original amount?
480.
480. And this one would be an increase, right? And this one, of course, is going to be a decrease. So what is that going to be, Jeff? I think that's going to be 16.7%.
Correct.
Yay.
How did you figure that out? How did you get
Say again, sorry?
8.7%?
How did I figure it out?
Yeah.
So the zeros cancel. 8/48 is 1/6, and I just know that 1/6 is 16.7% because it shows up a lot. I know I do a lot of statistics, and when you roll a die, the probability you get any number is something out of 6, right? 1 out of 6 or whatever. So I know all my out of 6s because I'm weird, right? So That one wasn't,
Great,
I
thank you.
calculated it just now. I sort of have it memorized, to be honest. Do you see how these are not the same? Even though they're the same numbers, why are they not the same? Because they're based on different amounts, right? Okay. I think my Wi-Fi is getting a little weird. I think that's enough for today. So let me know if you need to hang out for a bit. Otherwise, I will be back at 3:30. And the link, of course, I did put the link up in Canvas. It's up there now.
The tutoring schedule, like right now with the tutors that are there,
Yes,
how do we access that? Is it in the syllabus?
it's here. Let me show you.
Or they're in Canvas?
On Canvas. Yeah, it's
Okay,
on Canvas. Hold on. Let me show you.
okay.
Bam. Get in there.
I think it's on the left side. There we go.
Math tutoring. See it?
Okay, great.
You see math tutoring, and then it's got a whole little spiel, and then a link. So that link is active right now.
Mm-hmm. Great.
So yeah,
Okay,
11:30 to 3:30, and then at 3:30 I'll take over. Yay!
sounds good.
All right.
Okay, great. Thank you
Thank
so
you.
much, Professor. You have a great, well, I'll see you at 3:30.
Okay, I'll be there.
Okay,
I'll be here.
thank you. Bye, everybody.
Thank you.
Bye.
Let me know if you need to hang out for.
Bon
Otherwise,
voyage.
okay. I'm going to the other room. Huge trip. All right, I'm out of here.